right, we should be live. Oh wait, did I put the stream? Oh, yes I did. Okay. So, hello everyone, we are live. And we've got another physics build to test, well, another experimental physics build to try out today. Recently, one of the developers made a new branch for only the XPBD solver, not having the Jolt solver or the Bolt solver in it, which I'm not sure if this one is maybe a finalization stage. I don't know, but for the time being, it's just a new solver branch that has some new stuff, collisions and all that. So I want to go and try it out with all of you. So let's go and set this up from scratch, because I know a few people are, well, including me, were confused on how to do this. So first of all, I'm going to make it so that we can see the results. So we can use a gather bundle geometries node. And again, this is a special build. Actually, I should have put this in the chat. Let me go and do that real quick. But we'll gather the bundle geometries and output it there so we can actually see our results. And then for the input, we need to get a bundle. And here is the part that is a bit funny. There's a typed bundle, and then there's a combined bundle node. Now the thing is, these both are kind of the same, just with one different input. So if we add in a string input right here and label it type, it'll automatically become a typed bundle, which means it'll automatically go and look at all of the physics solver stuff. Now, this is part of the design that I assume is not finalized. I think they mentioned that in the build, which again, I will put in the chat because I just got it. Again, this came out yesterday, or the PR got put out yesterday. There we go. It's in the chat. So the design is not finalized. So I think this is one of those things where it's like, oh, once more solvers get added, this might get really, really big. But I would assume, like, in the final stage, once it gets connected, we would be able to see all the stuff only when it's connected and not before. But here we can see XPBD geometry, and then all the settings get output there, which is a nice part of the design. So we can do all that, again, not having to use named attributes or a ton of spaghetti lines going into the solver, which, again, is always appreciated. We have all that, and we can now see, once this gets going, or we should see, assuming that I did everything correctly, that we should see some points here. Let's see, what did I do incorrectly? Come on, buddy. Let's see, do I need... Oh, that is the world. So yeah, no, that should be fine. Run it again. Is it output correctly? Oh, because, yes, we need to connect the world to the gather, not the state. So here we can see we have all of these points, and the radius is way too large, so let's go and reduce it. So we have those, but what if we wanted some collision? Well, fortunately, there is a collision, a spherical collision setting, which, as far as I know, this is just a basic one that doesn't have like friction or restitution and all that. But as we can see, oh wait, we only have one world input. What if we want more settings? Or, well, that's where we can use a regular combined bundle node and connect everything into here. So everything just works quite nicely. So if we do that, we should see, boom, collisions, and all of them go around. Let me change the seed. But yeah, we can see that they're all moving around, and that works quite well. But let's go and add in a force. So let's go and get a force right there. Refresh it so that it'll go and show that. Let's add in a negative position force so that it'll move more towards the center. So let's set this to be like -3. So now, as we can see, it now tries to go towards the center, and in my infinite wisdom, I put the floor plane right there. So let's go and move the entire simulation up and do that. It simplifies stuff. There we go. So now all these will try to stay towards the center, but the collisions still happen. And we can see that this is running at 10 substeps. I'll lower it to 5, just because once you have like a bajillion particles in there, you might want, you know, some different stuff to happen. But now, in this version, they added in some, at least, initial implementations of geometry collision, which in the Jolt solver, it already had that, but this is the XPBD solver, which has a higher chance of actually getting into Blender, so I want to try it out. And this one is compatible with instances, which my current particle system, which is several years old. Well, actually, 2 years old at this point. Unfortunately, it evaluates collisions on all the geometry has to be realized before it gets the collision points and all that detected, which makes it rather slow. So I'm hoping that this is going to be a good amount faster. Let's see, this is, where's the collision? So let's go over to collision. Collider? Is this it? Oh, yes it is. So this one does not seem to have restitution either. But yeah, let's go and take a look at this. And there's a good chance, everyone, that I am wrong about a good amount of this. Again, I'm not too sure. But we can see that some of the collision is working. But perhaps not all of it. I noticed that having a low, wait, what is this? Again, a low compliance value works better. Now, I'm not sure if this is, I'm assuming it's actually getting the geometry and it's not a voxelized collision setup, because I know another developer was working on that. And at the moment, the collision does not take into account the size of the particles. But I assume that'll be put in there later. So that's a simple physics thing. As we can see, it's actually quite stable. With my other physics, with my particle system, particle interactions would not be this stable because we just couldn't do that with the first, only getting one nearest index and all that fun stuff. Again, with lower samples, we can see, you know, it still works pretty well. Even though I should probably turn up the damping. So let's go and get the, damping. Let's go and set that to be, refresh. Set it to be like 10. There we go, do that. And as we can see, once it's set up to be pretty high, damping does a lot. So with just one sub-step, we can see that there is some stuff happening, and we can still change the solver thing there. I am looking forward to when, does the mix node have, no, this does not have a enum input yet. Or wait, no, it was another node that I wanted to have that. Anyway, there are still some limitations on the menu sockets. But yeah, we have all that, and we can see that this is starting to get a little unwieldy right now, but most likely this will be put into a main node group so that you don't have to put in everything yourself. But the functionality, just being able to have a new node, check the functionality, and then put that in is very appreciated. Let's see, there's spherical self-collision, we got that. We got distance-based edge bending constraints, edge length constraints, which, oh yes, I need to try out that one, because I still want to try to make this work with my armature physics setup. But we'll see about that. Align positions. Oh, some of these are new. We need to go and try these out. But anyway, we're getting a little bit ahead of ourselves. So here is the real power with this setup. We just have one line, no spaghetti, and it just goes over here, and then we can do other things that we want. So here I'm going to use a curve line, and then I will go and make it so that it's resampled, so that we have, like, say, 100 points. On here, let's set it to be 100. Hello to everyone in the chat, how are you doing? And then I will go and set the curve radius. Set curve radius. And then, oh, what else? No, this should be good for now. If we do this and then plug it into there, we'll see that some things work, some things don't. We should see, yep, just as I expected, the curve is just doing its thing. Let's go and put it on the x-axis and then move it up a little bit so that we can, there we go. Yeah, we can see that the collisions are still working, even though I thought I said to, yeah, 0.1. 0.01? Yeah, for some reason 0.1's looking more like... Oh, no, I know why. Yeah, no, it's working as intended. Let's go and set up some other stuff. So maybe 0.01 would be better. Yeah, that's much better. We can see that that's happening, but the curve is not doing everything that it should. So let's go and switch out a few things. So another thing that I'm going to do is just generalize this a bit more. Actually, let's start out fresh with the combine bundle node. And we're going to move the generic stuff like the uh, collisions and the forces and the damping. Yeah, basically all that other stuff over to here. And then we can just join that into the fold later. Or, yeah, right there will be fine. The main thing is I just want this to be nice and generalized so that we don't have to keep everything so tightly knit. So again, that part right there. So this will be the XPBD part. And then we can put everything else we want in there. Now, I do wish that managing these was a little bit easier, but it's fine. It's fine. Let's go and have another typed bundle because I want to try the curve stuff. So let's go and get the curve segment, XPBD constraint. We can see that that just has a compliance amount in there, and then we can go and put this into there. Let's go and chop these out of there. So let's see what this does. I'm not entirely sure what this one does just yet, but there are other Oh! Wait, what? Something has changed, but I'm not entirely sure what just yet. Oh, it's a length constraint, isn't it? So I'll try to stay the same distance apart. Okay. So that's the curve segment. Okay. Now, there are other constraints that did something quite similar, but that's why I was slightly confused. So let's go to rod. There's the, nope, rod, bend and twist. So both of these, maybe they're being rolled into one here. I'm not sure. But these would, if we go and connect them and then chop that one out, we should see it does something, wait a minute. 0.001? Oh wait, do these not do anything anymore? No, they should. I tested them, didn't I? Interesting. Maybe these are being deprecated? Though I am not sure. Maybe if the value is a lot higher? I tested these earlier. Huh. Anyway, well, let's just use what works for the most part here. So that seems to work. But the bend constraint would make it so that these would try to stay aligned. Also, it should be noted that the collisions are not using the curve segments. It's only using the points, which is causing this kind of pattern. Because it's only the points and not the mid segments that are being accounted for. Okay, let's go and check for other things. I know there are other things I need to test. There's collider, force, gravity, which gravity... Yeah, let's go and just throw that in there. Let's do that, put it in the main part right here for all the, I guess, movement-based constraints. There we go. So we can see there that, hey, that's working pretty well, even at 2 substeps. So if we go and turn it up, we can see that it is, you know, having a good time. No friction on these, so let's go and turn that up to be 10. I'm assuming that's not a scale of 1, but yeah, that's actually... Oh, wait. The bouncing is actually... Wait a minute. Ah. That's what happens if you turn the compliance down. It'll go straight through. Let's set it to be 0.001. I don't know how this actually scales, so I'm just looking at this right here. Maybe negative? Or maybe just 0. When I had 0 before, some of them did clip through when I was testing this just a little bit. Okay, just making sure that the normals weren't inverted. On a side note, I really, really like how you only see the red where the normals are inverted. That's so nice. But we can see that's pretty solid. It's so solid that it's not even spilling over into the 3rd dimension, which I honestly thought it would. Let's see. There we go. Now it's spilling into the 3rd dimension, but that is stable. That's quite nice, isn't it? Okay. I do want to, like, the bending constraint, I thought would... Oh, is that oh, because has rotation is not enabled. Eh. Oh, we can see that's working now. So it needs a rotation in order to do some of this stuff. So let's disable gravity for now. Just chop it out of there, and we can see that stuff is occurring. Not entirely sure what, but something is occurring. We go and do this. We can see that the length constraints are still doing their job. So I'm not entirely sure what the difference between these are. Though I always love, we need rotation data. And at the moment, we can't extract the rotation data, at least not in the way I think. Separate bundle. In my genius, I have not named the bundles, which is quite nice. Oh, wait, no, that's initial rotation. We don't have the current. Maybe we can extract that from the states? No, we cannot. So the state just has the data in there. And unfortunately, I don't know, is that actually the... Let's take a look at this and see what kind of data we're working with. Let's go and do that. Spreadsheets. Take a look at the geometry. Viewer? Viewer node? Nope, the rotation values are not being updated. I would assume that that would probably be in the state bundle, or maybe it's just not exposed. You know, I always love getting as much data as possible, so it's like, I want all of the data. Let's see. There's a Windows build of this branch now. It used to be only Mac, right? Well, this is a new PR, which this one does work on Windows. I built it myself. This is just a light build, but a full build does work. I accidentally made a full build. I did a full build, then I was working on the constraints. So, oh yeah, in terms of like what I'm working on right now, I'm working on the attribute constraint, which I thought was almost ready to go, but a couple of the other devs pointed out some stuff that could be updated to newer versions of Blender, or newer Blender coding conventions, which meant I needed to pretty much remake redo most of the internal logic, which unfortunately was not as easy as I thought it would be. It has taken hours, but it looks like it's getting back to normal. It looks like it's getting close to being done. But also, with the other things, curves and point clouds are now supported, which I wanted to do anyway, but the changes have allowed for that to happen in a much easier fashion. Maybe I can make instances be supported, but I'm not sure about that. Oh, and for those of you who don't know, the attribute constraint would basically make it so that you can read data on geometry, and then make an object actually go to that data. So we would not have to do triangle parenting anymore. We would just be able to read like matrix data directly, which means that new functionality that I don't think is available in Blender at the moment. We would be able to scale by geometry data and do shearing data, which is nice. So we'll have all the power. But yeah, until then, we still have to do the old methods. But I was working on that, and then I built this version of this PR. So, anyway, what was I doing? So, I want to try these other constraints, because a lot of these may give us some soft body functionality. We'll have to see. But edge length is available, which means, yeah, that'll be good. So yeah, we have a curve right there. Let's go and put this into a nice little frame. We'll just keep that. And then, well, actually, I'll just copy that. We'll keep the collision there. We'll chop out you, because we'll only need to replace this part. And for here, I'm going to use an icosphere, because I want to test this. As we can see, and we don't need a radius value, so spherical collisions are not needed in this part. So gravity, yes, that, yes. Let's go and switch this to be edge length constraint. There we go. Let's So with all this, we should see, in theory, that it falls and then that happens. Yay. So again, we go. Is there a pressure thing? There should be a pressure thing in here. Pressure. Yep. There we go. Reset that. So again, hopefully, like if we can get like mid-segment collision and then face collision in this, I will be overjoyed. Because those collisions we just straight up cannot do in geometry nodes at this point. But what we currently have in this solver is already quite nice. Let's set this to be 0.25. We can see that that's working quite well. But if I had more geometry here, I don't think it would collide with its neighbors. But as we can see, as an initial, like, still quite basic soft body solver, still seems to work. But yeah, let's make the pressure... Seems like this solver is still a little bit funky with it. Is it taking the average and then doing the pressure based off that? That would explain why all of that is a little bit funky. Make the edge length compliance a lot less, if possible. There. Oh. It likes to spin. There we go. That's a little bit better. There we go. Okay, yeah, no, the pressure's correct. It was just that the edge lengths. There we go. And if we turn that up, it makes it a bit better. Now we have that. So again, if this makes it through, that will already be a huge step in simulation nodes actually getting simulations. Which it's been like, how long has it been since simulation nodes first dropped? It has to have been at least 2 years, maybe 3. Actually, when did Blender 3.6 release date? 2023. Okay. So it's been just about two and a quarter years. Yeah. It'll be nice to have an official solver. Because making our own, it has gotten me quite far. Again, a lot of simulation nodes stuff I've used in professional environments. But it'll be nice to have official solvers. Or an official solver, because that would make things a lot nicer on my brain. So we have that. Let's see what other stuff we can do. So edge, distance-based edge bending constraint. I'm assuming that this one is only edge distance-based. Yeah, that one's still. I don't think that one will stay around. Align positions. Align positions. What is this? Oh, it crashed. Wait, what? Wait, how? Wait, what? It crashed, but then it uncrashed itself. Oh. How? It automatically loaded the autosave? Oh, that is weird. I haven't seen that before. Why would it automatically load the autosave? Is that like... Huh. Well, now I need to redo the name. So I'm saving that to not an autosave. Okay. That's new. That's cool. Okay. Okay, what was I doing? That was the align positions. Was it because... Let's not that... I don't know what this does. And also, it's... Huh. If we try this... Nope. Dang it. Okay, well, let's try reloading. Whoops, the wrong one. Close. Probably move that down. There we go. Interesting. So that one just crashes. Base. So we have that. Let's go to... We don't... Infinite ground plane. We don't need that one. Oh, all these have rotations too. Glider torque. The torque would make it so that we can rotate the points at the very least, but we still cannot extract the rotation data as far as I know. There's attached UV constraint. Now this one is very interesting. I'm assuming that this one is still a work in progress because it doesn't have a mesh input as a mesh path, which if this is what I think it is, it would like put in the actual mesh path as a string, which is weird. Yeah, unless there is like a data block to string, value to string, strings occur, format, match, replace, slice string, string length, yada yada. No. So I know the devs have, I know this works because the devs have tested it. But this one is interesting. Unless there's a pin position. Wait, no. Pin, this is pin position. Yes, so if we do that, we can then do this through the normal way. So I think this will be fine. We go and get like an object over to here and then sample the position from that. It'd be fine. If we do this, again, let me Control-C, Control-V, move it down to here. So if we then get a sample UV surface, we should be able to do basically what that thing does. Except here, we'll go and get UV map, which I assume will just be UV map. Yep. Then to there, and then the sample. That should work in theory. Let's save this before I do that, just in case it crashes. The crashes can be as interesting as everything else. Okay, so that'll go there, and then the selection will just make this a random value, make it so that it's a very low probability. And now we can see that to be relative. Ah, it does work. Okay. So it's probably much more efficient to use the one that that is just inside here, but that one crashes. So, or no, it doesn't crash. We can't. I don't know how to access the mesh data just yet. So yeah, so here we can see that this maps and can go there and there. So the pinning is also dynamic, which is good to see. But then again, I already knew that. So again, this can work on fur and all of that. Should I try fur? It's probably fine. Don't need to do that right now. But then the pinning for that's fine. Let's also take a look at, let's go and compress that. Come on, buddy. There we go. Now let's go and get the pin rotation. Again, this is very interesting. Very interesting. And then there's a filter, which I assume will just be like a mesh filter. But we could do that as well, because this does have rotation, but the rotation isn't. Oh, shoot. I forgot to set the output rotation because the node was collapsed. We probably... Okay, I need to test that. 1 second, everyone. Conveniently, we can just go and do that, plug that into there, and then we can go and take a look at that. So, in theory, we probably can get the rotation output. So if we do that, no named attribute, but in theory, wait, no, the devs have done this before. Let's go and separate bundle, and then separate the bundle, which that part of the UI is still a little bit funky to me. Because, yeah, would there be a way to like extract types as well? Because right now we can only combine types. Actually, is there a separate type? Separate type? No. Not from what I can see. Okay, so does... It crashed. Lovely. Restart. I assume, yeah, this is taking it from the autosave. Let's go and separate bundle. Again, crashes are expected at this time and space. So if we were to take a look at that, let's make sure that that does not crash. That crashes. Restart. Why is that one crashing? I don't get it. Oh, is it because wait, why was has rotation disabled? Anyway. Oh yeah, and of course the rotation's not moving. Nothing is affecting the rotation. If I were to pin it, then that would work. Okay. I'm slowly getting the hang of this. What the? Oh? What happened there? Did I do that? Yeah, what happened here? Oh, because yeah, no, never mind, everything I think is working for the most part as intended. I'm just tripping over my own feet. We can see rotation, that's the initial rotation. But if I were to pin the rotation, so let's do pin. In theory, this will work. So let me, 1 second, everyone, as I go and, okay, I'm gonna move, be right back down to the bottom of the OBS stack. Muscle memory says that's gonna happen. Let's go and save this again. There we go. Okay, this is interesting technology. So we can do that, and then in theory, okay, rotation now updates. Nice. Okay. So again, this was me being dumb. I apologize. Has rotation, we need an output rotation. Or actually, do we even need an output rotation attribute? Yeah, okay, no, we do need that. It was just, that was hidden, so I missed it again, even though I've done that before. Oh, yeah, output rotation name. Because named attributes are the best. I love named attributes. You love named attributes. They're the best thing to ever exist. The bundles are pretty cool as well. Okay. Okay. Let's see now. Okay, let's add in gravity. Just plug that into there. Connect it right there. Do that. You love to see it. So, if particles support rotation on their collisions, turn off the pinning. I would not assume that rotation. Yeah, no. Size is not taken into account with the particles. I would highly doubt that rotations are taken into account for the collisions. But again, this is early on. I'm just experimenting. This is not like super official or anything. I'm just playing around with this and seeing what is what. Okay. Combine bundle, all that seems to be fine. Yada yada. What else was I going to do? I did want to, again, here's the rotation part right there. I think this being filled in by default, I think could be a good idea. Okay. I notice most of this is rigid and soft body. No rigid bodies in this part yet. But I wonder if they can allow for fluid sims. Well, fluid sims, it depends on what kind of fluid sim you're doing. There are particle-based fluid sims, and then there are volume-based fluid sims. In theory, a particle-based fluid sim solver could happen, and a grid-based one as well, but I would say getting basic simulation support would be the first line of action. Also, speaking of which, why are you doing that? Is it because the bending constraint is so... I keep forgetting if I want this to be high or low. Because in the setups that the devs had, there was like a converter that I don't have at the moment. Let's see. Particle-based fluid sims. I don't like volume-based since it's always contained in an arbitrary domain. Yeah. In theory, yes. Like even right now with the spherical collisions, you could be like, oh, that could work as a fluid. But again, actually, no, that's a bad idea. But if you wanted to, let's go and set this up to be, this is too many particles, but oh well. Oh yeah, it's lagging. Too many particles. All the particles are basically in the same spot, so resolving this will probably be the worst thing on Earth, which is why I should not have done this. I shouldn't have done this. Just shouldn't have at this time. Yep, it's taking way too long. Well, I have time. We're at only 35 minutes, really? What? Please hold. Oh no, it is lagging my entire computer. Oh, buddy. End process, end process. Come on. Oh, gods. Let's reload it. So the problem there was that I had too many particles in the same space. Let's go make this be like maybe 5 and set this to be 10,000. Or 1,000 for now. So we can see here, it's like, oh yeah, that could possibly be, let's go and get gravity. Do-do. There we go. So we can see, oh, it's like, oh yeah, you can, maybe that could work as a fluid, and then you go and mesh it after the fact. 10,000 particles. Again, we have a massive slowdown just because, well, it's only 10,000 particles. Maybe 10,000 is just a bit much. Computationally. Or maybe there's like, I don't know what acceleration stuff is missing or supported or whatever. But yeah, and also let's throw on a solidify. And say here. Solidify. Look at this. Oh, my stream's buffering. You don't say. And let's also do normals, weighted normal. No, not weighted normal. Normals. Smooth angle. There we go. That's the right one. So here we can see, yep, the collision. Oh, no, the collisions are working. Though, due to the high amount of particles, they're still doing some stuff. Oh, I should also mention, I took a look at Houdini's new NPM solver. And apparently, like, there was like a demo with like a cookie being crushed and then milk being poured in and then like all physics stuff, like the cookie was properly like semi-dissolving and all that. Apparently, on a 4090, that took 10 minutes per frame, which it had like 10,000 sub-steps, which is a long time. Just keep that in mind. Like if I set this to be 100 sub-steps, we can see that we're getting a crisp 1 frame per second. But the collisions would be pretty good. Pretty good. I also wonder, right now the sub-steps are just kind of global. I wonder if there would be a way to set, yeah, there would probably, yeah, just have an integer value for like, oh, if you have spherical collisions, you can set the amount of steps for that individually. But yeah, I would assume that's possible. I mean, I put that in my particle system ages ago. Yeah, that exists. So in theory, you could make a fluid simulation with this, but yeah, the performance would not be kind. And it seems like the collision is the main choke point here, because that's just with a little bit more geometry. Okay, let's go and turn that off. We can see, yeah. Was this, yeah, no, we're back to 10. Let's set it to 1. And right there, yeah, performance optimizations can always happen later on. But we can see there, quite a few particles. I'm assuming the self-collisions are the main slowdown. And then all of that, which is cool to see. But I want to try out some other stuff with this, because it's cool to see that that's happening, even if rotations aren't available. But we have positions, we have rotations. For the curve, let's go and plug this back in. There we go. Let's take a look at that. So we have you. That's there. Where? Oh, gravity. There we go. We can do that. I want to see. I want to have multiple of these. So let's go and duplicate elements. Set this to be spline. Use a nice set position node. Let's have 100. But we need to make it so that they're not all in the same place, or else things will go horribly wrong. We need a vector math multiply into the offset. Set this to be 1, and we'll plug it into there. So now, if we take a look at this, we can see that it was moving so fast that I went straight through. Let's have 10 substeps. What was that lagging? And it's not stable either. Let me go and check. Let's use just this one and see how that goes. Because I assume... Dang, yeah. Actually, we can go and test what's the slowdown here. Okay, so collisions aren't that bad. Is it spherical self-collisions? Yep. Yep, but we need those. So yeah. Little bit slow. And we only have, wait, we have 100 times 100. Oh, okay, well, yeah, let's set that to be like 10 instead. That happens. Because they're just going way too fast. But I thought 10 substeps would be good enough. Looks like it's trying to glide. Maybe they're just going too fast? Let me make the collider a lot thicker. Okay, well that works. Maybe they were just going too fast. There we go. Okay, so we have that. So that wasn't the problem. So let's go and re-enable these two. So now, there we go. Now, since that stuff oh, that is funny. They're trying to stay the same length. Good. So let's go and play around with that. Let's also, is this an autosave? No, okay, it's the main thing. Okay, so let's try to do some fun stuff with this. Oh, I can try Spiral. A dev a long time ago tried out a Slinky kind of effect. And now I think, in theory, oh, that's cool. Look at that. Yes. Me like a lot. Let's see. See that it's trying to stay upright, but the bend part. Oh, we can see some like wait. Let's go and set this to be a bit lower, but I want more rotation. So let's set that to be like 6. There we go. Oh wait. That's funky. Oh, is that because it's colliding into the floor? No, that wouldn't be the case. Oh wait, I need to store the initial rotations. That's why. But we can see right there, that's looking pretty cool. So the initial rotations would have to be the curve tangent, a line of axes to rotation, primary and secondary. So primary would be that, secondary would be the normal, and well, true normal. Curves have true normals, right? Plug that into there. Output rotation, save, and run. There we go. So we can see, well, it's trying. It's trying. Maybe I still need to actually try the compliance thingy. Because there, yeah, we're getting similar results. We need to see if we turn compliance down to 0. Absolutely no compliance. Something's happening. Did I set this up incorrectly? Let's test this. Oh, is it the inertia? Because the inertia setup was, maybe not. ZX. Maybe that was it. And then setting that to that. Okay. So, okay, so yes, the inertia, I assume, just has to be based on the distance of the segments. So yeah, I would need to refer to the thing there. Yeah, more points, the harder it is for it to do that. Stiffness is always a pain with this. But if I set up the sub-steps to be like more like one, there we go. See, that works. Right now, if I run a curve to points, this is quite interesting. You can see, oh wait, that's not too many points. Just the, yeah, just the, those, yeah, so having the different subsets for different constraints would be nice, because I don't think I would like doing 100 collision constraints and along with the 100 stiffness constraints, even though that might be a good idea. So if I were to say rotate this, we can see that that happens, then that happens, and then that happens, which is cool. Let's set this to be 25 to bring it down to it's only one spring. It's like, oh, Slinky. We can do that. But also, let's make this quite a bit smaller. Let's set this to be 0.25. There we go. So we have that, and we can see that it's trying its best. Let's set this to be 20. So right now, yep, it's a spring. Not quite a Slinky, though. Let's set the rotations to be 25. It's trying its hardest. It seems like, let's see, it's almost working. Cool. Okay, let's reset EU. Let's add in a noise force. Just for kicks. Also, let's have 2 Slinkies, even though they will not intersect properly because the collisions do not support thing. So it looks like they're colliding, but in reality they're not quite. So we can, oh wait, it's being, I was like, does it look like it's being held up? Because I specifically put that into the setup. Yes, I keep forgetting things I put in here and assuming that the thing is malfunctioning. But in reality, it's doing exactly what it's programmed to. It's me that's the problem. Let's throw in a much stronger force. Yeah, there we go. Maybe a little too strong, but turn off the forces, only keep gravity. The cube here, and then rotate that. Come on, you can do it. You can do it. There we go. So maybe Slinkies would work. Who knows? Maybe just like angle it a bit. And then, actually, friction is enabled. Yeah, like that. You can see it, it's trying. Oh, is it because damping? What's the damping here? Yeah, let's turn damping off. So if I made proper steps, which, oh, that would be so difficult to do. If I made proper steps by, let's say, if I had time, just by doing, okay, I get it, buddy. Just by doing that, then, or actually, no, steps are not 1 meter tall, so let's just do that, that, come on, you can do it, buddy, that. Yeah, that seems to be good. Even thickness, nope. All right, well, we're just gonna have to deal with that for now. Because of that, yes. Now, if we take a look at this, and we make it so that these have a little bit of oomph, should see. You can do it, buddy. Come on. You can do it. No, just a little bit more. Come on. Do it. Do it. You can do it. I know you can. Hey. Almost. Almost. Oh, and whoa, they got sent into the stratosphere there. Oh. What happened? Oh. The collision's messed up. They really went into the stratosphere right there. So yeah, we have both of those. Let's go and if I turn off, no, not the geometry node side. I need to, yeah, let me go and just gather. No, then again. Anyway, let's go and reset the cube. Oh. Why did I turn that off? Okay, so springs do function. Let's see. Let's see. The collisions are always the killer. I can't seem to take all the isolated tutorials out there for different forces and bring them together. And I never see anyone using the latest updates implement dampened bounced for particles. Oh, do you, in my everyday node group assets, which is up for free on my Gumroad page, there are some node groups that help with bounce collisions, which include bouncing and stuff like that, where you can make it so that it bounces just a little bit or a lot, and friction is also enabled. And also, I have a particle system out for free on Gumroad that has that as well. So I would recommend taking a look at both of those. And one of them's in a modifier state, so you can just plop it in your scene and do all of that. But yes. Man feeling like Bob Ross for Blender. Oh, hey, thank you. I don't quite have the calming voice that Bob Ross has. Mine is a bit more frantic and fast. But Bob Ross is a legend. Yeah. Let's see, so we have the initial... Oh wait, no, that's that part. So we do have that. So if I were to instance on points, but I want to... looks like I'll need to separate the bundle. That's not too bad. Separate bundle, separate bundle. Go, put that into there so that in theory... Uh-oh. Huh? Why would that not be found in there? It's right there. Maybe because it's a named attribute. Let's go and get the rotation. Plug you into there. Why? Weird. And I need, oh, right, the cube. So if we do this, we should see that the cubes are aligned. Now, if meshes can also, or like edge lines can also support this kind of curved-based orientation, which maybe it can, but we did try and note the bundle part that I thought could do that and it crashed, so maybe I'm a bit wrong when it comes to that. But you can see the power, can't you? There's so much power. Almost here. So close, so close. You see that that doesn't fully align with the tangent. Oh, because of that. Yeah, so if I had a cone, that would work a bit better, potentially. Yeah, okay, so that's good. We can see that it's just that, which means that the other parts aren't there. So let me just go and not take that into account. But yes, that's looking cool. The outputs are looking cool as well. We're coming up on an hour, so I think I'll go and stop streaming soon. But it is quite cool to see that this is working as intended. Quite cool. Let's go and take these. I want to have a cool particle system that's doing wibbly wobbly stuff. Wibbly wobbly. So we can just go and add in the forces here. Plug that into there. Let's plug that into there as well. So this will lag again. We know this. Crisp 3 frames per second. Oh, but quite a few sub-steps. Yeah, that explains that. So that's a little bit much, don't you think? Let's go make the scale quite a bit less. Let's take a look. Okay, so collisions again. It is somewhat comforting that even the devs find collisions to be quite painful. Let's see. Quite funny. Wait a minute, why is it trying to pull? Oh, because gravity. Yeah. Let's turn off gravity. Now they should congregate there. Let's set this to be like 5. Oh yeah, I need to test the other methods here. Ooh, that looks very blobby and good, but then again, only 10,000 particles. That particle flew out into the void. And then this one has, yeah, several other options. Okay. So let's try, I still want the noise. I want it to be stable, but just going through some other motions. Do that. And also the size can dynamically update, which is cool. Something like that. Let's go and save that in its current state. Want to go in instance on points so that we can get some nicer looking geometry. Icosphere. Let's go and get the radius and put it into there. Going to go and use a set material node. Tap the material. Eevee, this is a light build, but this should work. Earlier today, materials were crashing immediately, but that got fixed, which is nice. Set shade. Shade smooth. Also, I really like the new singular value shape. I like that. I know some of the socket shape changes people have been less than thrilled with. I've been liking it. Okay, all that's good. Just because like it's just one. It's just a symbol for one, and it looks great. Let's go and turn on ray tracing. Ooh, look at that! Wow. I've had my gripes with Eevee Next, but it's starting to grow on me, especially with Vulcan. It's feeling a lot more robust this time around. Then all that should be fine. Two. So we have all those, which means that in the center are probably the smallest ones. Yeah. But I want the size of these to change dynamically. So you know what we do in that situation? We go and get another noise texture. We go and offset this randomly. Let's say 100 seems good. Then we add the scene time seconds into the fold. We go and do this, turn on normalize, and then we can use a nice little map range node to set this to be a reasonable range. So maybe 0.01 to 1. We go and put that into there, and then watch the sim explode into a million pieces. But here we should see. I had my retainer in last night, which messes with my pronunciation with S's. But anyway. Why are you here again? Oh, right, you were a test. We don't need you here anymore. Okay, we have that. Let's go and just make you a lot bigger. Yeah, that's looking a lot better. We have that. Now let's go and actually change the said material. Let's go and bring this up to have a nice environment. Let's go and change this so that it's a nice orange. But I'm going to do something that a lot of people will roll their eyes at. I'm going to switch it to... Oh, right. This was the light build, so I don't have all the color spaces. I should have done a full build, but it just takes a lot longer. Oh, well. Let's go and use... oh, wait. No, we need object info random. So that we can color these randomly. Color ramp. There we go. Okay, alpha and using render view for normal use. Sorry, I don't understand what you mean with that. Seems to be good. For some reason, the ambient occlusion seems to be very overzealous, but it gets like almost turned off at the edges there. Is that? Yeah, why would that be? Yeah, the AO seems to be wrong. Also, wait, something's wrong. Everything looks like it's floating still. That should not be the case. I know, the AO just seems very wrong. I don't remember it being like that, even in 4.5. I could always be wrong about that. Let's go with... Again, this is standard, so we're not getting the very nice looking colors. Subsurface, yeah, let's go and turn that on. Set this to be like that. Turn it up. Yes, looking nicer. Let's switch this to be more of... Yeah, that looks like... Oh, what are those things? The beads that would grow when you would put them in water. Oh yeah, that's looking nice. Let's go to... Nope, we don't have any looks that we can do. But yeah, we can see... Yeah, if I light this correctly... Work quite so well. If I... And also, I'm gonna do a full build. I can't make this for too long. It's so annoyed. We have that, so the particles will still change size. Oh, how did I... Oh, wait, that's weird. Oh, no, that's expected, yeah. Also, the compositor is... Where is this bloom coming from? Wait, that's not bloom. Wait, is it? Yeah, no, okay, that's not bloom. I was like, wait, why is the bloom doing that? But yeah, I need to get the other color spaces in here. Shadows are looking nice. Let's make this one a bit more varied. Yeah, nice little particle system. I can post that tomorrow because I've been a little busier than usual. Yeah, that looks nice. Or no, that looks nicer. Fun little tip, if you ever want your renders to look nicer, your stylized renders, get your ambient occlusion and use it to hue shift your colors, or set it so that's just a different thing. Let's go and use a subtract node. Not vector math, come on, buddy. You can do it. Do that, so that's like that. Go take a look at that. Yep, that's looking good. So if you hue shift, we can see that the colors just look a little bit better. You could go and make it a very stylized, like that, but if we take a look at this, oh, that actually doesn't look too great. But that actually looks not too great. Dang. I'm assuming this is because this is standard. No, just a little bit. Helps a little bit. So again, with it disabled, enabled, it just adds in a little bit more. Viewport denoising is on. Always turn that off. Motion blur, how's that looking? Oh, yes. Yes. Quite nice. Let's see. I am liking, I always lean towards it. Oh, that looks like, caviar a little bit. We switch that just a little bit, just a tiny hue shift. We can see that. Then for the ground here, oh, nope. What would be a nice complementary color? Not quite that. Oh, yes. Quite like that. And then, no HDRIs because we built this slightly. That can work as well. Either that or that. Nice bold colors. Then, yeah. I'll do some testing. We need more. When in doubt, add more rim lights. Oh no, this one's not rim light, but you know what I mean. Oh, just do. Actually, what if they were very dark, like almost black? What would happen then? Cool. Now that looks a bit more like caviar. I just wanted to see like a little bit of subsurface scattering. Let's see. Then with it being like that, it just looks like styrofoam a little bit. Use the subsurface scattering. Ooh. That could do some stuff. It to be that, and that's just even. But that... Well, if we turn down the red, we get something like that. Which, the AO doesn't seem to be doing anything in shadow, which I guess is right. It's doing a little bit. Not a ton. I just need the right color space. And we are past an hour by 5 minutes. So I will need to end the stream. We can see all the other colors. How sharp the transition from that is. That's looking cool. I want to get a nice render of that. Maybe a nice, almost macro render of that. Maybe some depth of field. Yes. Yes. Depth of field. Do. Ah, yes. Quite nice. It's a nice little example of the geometry node, the possible future for geometry nodes, motion blur and all that. But that looks nice. Yes, let me read the chat before heading out. How much performance would this save should the particles be transformed into a mesh, calling particles that would be inside its geometry? How much performance would this save? Oh, like... if you can't see the particles, they're not instanced on. I don't think that would be too much time saved. Like, all the performance things happening here, I think it would all like have to be optimized inside the code, which I assume that they're using, I don't know what they're using under the hood. I haven't looked at it yet. Like points to volume and then volume to mesh. Oh. I'm not sure. Actually, yeah, let's try a quick little mesh to volume, volume to mesh setup. So here we have the points. Now let's do points to volume, and then points to volume, and then to mesh. Let's take a look. And also set material, all the same. Huh? I need to make the full build. This was compiled without OpenVDB, so unfortunately, yeah, I'll go and do that off stream. I'll just let that cook in the background while I have to do other stuff. But we should see that also the sizes should be changing. There we go. If I turn that up, we should see that particles are changing size. Yes, that is good. That is good. Very good. So, yep. Okay. And I could try making this a two-dimensional simulation, which may look cooler. But anyway, thank you all for watching. I hope you enjoyed this nice little look into a possible future of Blender. There's no guarantee that this will be in Blender 5.0. This is an experimental build. The design is not finalized. So just keep that in mind for now. But anyway, thank you all for watching. I hope you all enjoyed, and I will see you next time. Have a good one.